transitioning into notes. I just want to do one quick reminder. On the test, on Friday, it does say that it wants you to solve in all of the different ways. So I do want you to be able to solve each of the different ways. If on test day you're struggling because you're like, I know I can solve, but I can't solve all of the ways, call me over at that time and we'll talk. But I want to say that now, sooner rather than later. But today I'm not giving you another form of solving. I am giving you a different type of solving, I guess. It makes sense when you get to it. Giving you different types of equations. That makes more sense. Because section 3.5 is all about nonlinear systems of equations. What are systems of equations? What's it mean to have a system of equations? We did it in chapter 2. That's a system of equations. What makes a system of equations a system of equations? What's this guy? 2 equations. Technically, it's 2 or more. We're going to deal with 2 equations. And in chapter, I believe it was 2. Was it 1? Actually, it may have been chapter 1. We did systems of equations, but we specifically focused on systems of linear equations. Today we're getting to the nonlinear ones. Thankfully, how we deal with the nonlinear ones and how we deal with the linear ones, very, very similar. First off, there are a couple of different ways to solve a system of equations. One option is by graphing. Let's say, for example, I have this system of equations. I want to solve it by graphing. So I'm going to make myself a little graph. And I'm going to graph each of my equations. To graph a linear equation, like the second one, you start with the y-intercept and then move with the slope to get that equation, assuming it's in slope-intercept form like this one is. What is the y-intercept of the equation y equals negative 2x minus 1? Negative 1. Specifically, the coordinate point, 0, negative 1. So it hits right there. What is the slope of y equals negative 2x minus 1? Hint, there's only one other number in the equation. Negative 2. How do you move with a slope of negative 2? Slope is rise over run. Negative 2 is negative 2 over 1. If I want to rise a negative 2, what direction am I going? Down. Because if you're trying to rise, you're trying to go up. But if it's negative, you go down. So I'm going to go down 2, and it's over run. When you're running, you run horizontally. What direction? To the right or to the left? To the right. You're going to run to the right. It's kind of like reading a book. You go to the right unless there's some reason not to. Okay, so I would go here. Unfortunately, I've run out of room on my graph, so then I do the opposite. The opposite of going down 2 and right 1 is going up 2 and left 1. Ta-da! There's the second equation graphed. Now I would need to graph the first equation. To graph a quadratic equation, easiest way to graph it is to make a table. But you don't just want any table, because a quadratic equation, what does a quadratic equation look like when it's graphed? What shape? A U shape. It's a parabola. If I make a table with just generic x values, I could be looking at this part of the table, or of the graph. Is that going to give me the U shape? No. So I want to make sure I'm centered around this piece, specifically centered around that point. What is that point called on a quadratic equation? The vertex. This equation, is it in intercept form, vertex form, or standard form? It's in standard form. So I want to find the vertex in standard form to know where to center my table. If only there was a little like baby equation, maybe has something to do with B's and A's. There is. Negative B over 2A. Sound familiar? By the way, this is the equation for the axis of symmetry. And I told you at one point that I would tell you where it comes from. And I kind of never did that, right? This is what we did yesterday. This is quadratic formula. Where does this equation come from? It comes from, the negative b over 2a equation comes from quadratic formula. That's where it's built from. So, anyway, what is b on this equation? Negative 2, so I got a negative 2 over 2 times, what's a? 1. That's 2 over 2, which is just 1, which means when I make my generic table, I would want 1 to be in the middle. Why did I write 0? Try that again. I want 1 to be in the middle of it. That way, when I'm looking at the quadratic equation, I'm focusing in on centering on that vertex. Which means I want 0, negative 1, 2, 3. Those are the numbers smaller and bigger than 1. And then I would plug them into my equation in order to find them out. Do you trust my ability to plug them in? Beautiful. You'd get a 2, you'd get a negative 1, you'd get a negative 2, a negative 1, and a 2. If you center around the vertex, your table should be symmetric. Because if you center around the vertex, coming off of the parabola, it should be symmetric. So, anyway, we would plot these points then. Negative 1, positive 2, 0, negative 1, 1, negative 2, 2, negative 1, and 3, 2. And my parabola would look something like this. Now note that my goal was not to graph. My goal was to solve by graphing. What's the solution? The coordinate point 0, negative 1. The solution to a system of equations is where the two equations intersect. And they intersect right there at 0, negative 1. Now, bringing back something we've talked about when we talked about systems of linear equations, and even talking about solving just a plain quadratic equation. When is graphing typically the best way to solve? When you're given the graph already. Because in order for me to draw this graph, I had to put a lot into it just to get the graph, and hopefully I didn't make a mistake in all of the steps that I did. Hopefully I didn't make a mistake on plotting the y-intercept of this linear equation. Hopefully I didn't make a mistake in moving with the slope of -2. Hopefully I didn't make a mistake when finding my axis of symmetry of that U-shaped graph. Hopefully I didn't make a mistake when I plugged in all 5 of these numbers. So, graphing is not the best way to solve unless you're given the graph. If you're given the graph, it's fantastic. Let's find a different way. Let's find a better way. But I wanted to bring up the graph because recognizing the graphs is going to help us with kind of noticing something about possible outcomes. I don't know why I started making that a Q. That's a no. Because today I'm giving you nonlinear systems of equations. A nonlinear system of equations just means a system of equations where at least one of the equations is not linear. Which means at least one of the equations could be quadratic, could be absolute value, could be exponential, could be radical, could be logarithmic, could be trigonometric. Now, there's a lot of different things, and there's an infinite number of more options. Today we're going to get quadratics, and we're going to get a mixture of having a quadratic and a linear, or having a quadratic and a quadratic. So if you have a quadratic and a linear equation, when I graph the equations, they could do this. They could do that. Or they could do this. When I graph two quadratic equations, they could look like this. They could look like this. Or they could look like this. And there's a lot of more options on kind of the general setup of what they can look like. But the point I'm trying to get at is, how many possible solutions are there? No, that's not these. If this was my graph, how many solutions are there? 2. If this is my graph, how many solutions are there? 1, because there's one intersection point. If this is my graph, how many solutions are there? 0. Specifically 0, what type of solutions? Real solutions. You're not going to find imaginary solutions. These ones. 2 solutions. 1 solution. No solution. So, when solving a system of non-linear equations, you could have 0, 1, or 2 real solutions. So that's something to keep an eye on. And to a system of equations, the solution is not a single value, it is a coordinate point. So let's get to the way that we're generally actually going to see these equations, the way that makes a little more sense to work with, because realistically, we're going to have situations where we don't want to graph it. When we did systems of equations, when we did linear systems of equations, there was two main ways that I taught you how to solve. Substitution and elimination. Both can apply to quadratics, but in quadratics, substitution is generally going to be the better option. To solve a system of equations by substitution, you start by getting one of the equations to where the variable, specifically when it comes to quadratic systems, it's going to be y that you want to do this to. So get one of the equations where y is 100% by itself. Which equation does it look easier to get y alone on? The second one. How do I get y alone? Subtract the x, because then the y is 100% by itself. Y equals 4 minus x. Ta-da. Now, the key feature of a system of equations is that the x's and y's in both equations have to be the same number at some coordinate point. Which means, if this y value right here is equal to 4 minus x, then this y right here needs to be equal to 4 minus x. So I substitute it in. When you substitute something in, it should be in parentheses. So I substitute in. I get x squared plus x minus parentheses 4 minus x close parentheses equals -1. Sometimes the parentheses are not necessary. Other times they're 100% necessary. In this case, do the parentheses make a difference? Yes, because something's getting distributed into them. If there is anything happening to those parentheses, whether it be there's a squared on it, or there's something getting multiplied by it, you must distribute it in. X squared plus x minus 4 plus x equals -1. With a nonlinear system of equations, as soon as you've substituted in, you are now down to a single quadratic equation in a single variable. To solve a quadratic equation in a single variable, you can use square roots if it applies. You can use factoring if it applies. You can use completing the square, or you can use quadratic formula. I'd start by combining like terms, though. X squared plus 2x minus 4 equals -1. Which way I choose to solve depends upon what the equation looks like. First thing I look at is that x squared. Does it have a number in front of it? Has the invisible 1, but if it's got a 1 in front of it, my brain says factoring is going to be the easiest way if it works. In order to solve by factoring, what do you first have to make happen to the equation? Equal to 0. X squared plus 2x minus 3 equals 0. When it's got a 1 in front of the x squared, I can do the shortcut to the AC method. That's my goal when solving by factoring. If I can avoid the full AC method, I avoid the full AC method. Do you still have to factor on your guys' test, even if it's AC method? Yes, there is a section that is specifically factor. But for solving, if I can avoid AC method, I do. Okay, shortcut says two things that multiply to negative 3, but when I add them, I get 2.
3 and negative 1.
A positive 3 and a negative 1. In the shortcut, do I have to do the rewrite? Do I have to make it 4 terms?
No.
In the full AC method, do I have to do that?
Yeah.
Yes, so be careful of that. In the shortcut, I could go directly to my double parentheses. It's an x plus 3 and an x minus a 1. What is the only way those things multiply together and give me 0? One of them is 0, which means either this x plus 3 is equal to 0, in which x is negative 3, or this x minus 1 is equal to 0, in which x is equal to 1. This is a system of equations, which means we are not done because the solution to a system of equations should look like what? Coordinate point. Do I have a coordinate point? Can I make a coordinate point out of 2x values? Also, no. To make a coordinate point, you need an x value and a y value. How many solutions is this one going to give me? 2, because it gave me 2 x's, which means it's got 2 y's that go with it. If I have an x value, how do I find a y value? Plug it in to either of your original equations, or if you'd prefer to plug it in the version where you got y alone, plug it in there. That's the easiest. The one where y is alone is always going to be the easiest. So, when x equals 1, y is equal to 4 minus 1. 3. One of my solutions is the coordinate point 1, 3. The other x value I had was negative 3. When x equals negative 3, y is equal to 4 minus negative 3. 7. The other solution is negative 3, 7. Solving a system of nonlinear equations starts a little bit different than what we've been doing, but it ends, or at least the middle part I should say, is going to fit with what we've already been doing. So, let's try a couple more examples. This next example, both equations are quadratic. How do I know they're both quadratic? They both have x squared. Go be awesome. Assignments, go assignment. Again, to solve a nonlinear system of equations, we're going to solve by substitution. To solve by substitution, what do you need to have true first? Guess-ish? I wouldn't call it a value. I need a y that is alone. I need an equation in the form of y equals. Which equation is going to be easier to get y alone on? I personally would have gone with the second one. The first one's not terrible, but I personally would have gone with the second one. X squared plus 2x plus y is equal to 0. To get y alone, I move both of these. Y equals. Make sure when you're moving things around You are combining like terms if there are any. Now in this case there aren't any, but if there are like terms, make sure they do go together, otherwise you're making your equation way more complicated. Y is equal to negative x squared minus 2x. And if y is equal to that there, it's equal to it both of these places. But which of the two places do I want to plug it in? The top one or the bottom one? Has to be the top one, because this equation came from the bottom one. It has to be in the other equation. If you plug it back into the equation that you manipulated, you're going to be told that those two equations are the same equation, which of course they are, because you took the second one and manipulated it. So you have to plug it in here. Has to plug into the equation that you didn't manipulate. 2x squared minus 5x minus, when you plug something in, always put it in parentheses. Negative x squared minus 2x equal to negative 2. Are those parentheses making a difference? Yep. Because I have to distribute this. They don't always make a difference. Sometimes they do. Distribute the negative, I get a plus x squared and a plus 2x there instead. Do not forget to combine like terms. If you don't combine the like terms, you're going to make your life a heck of a lot harder. 3x squared minus 3x equal to negative 2. Last one I solved by factoring because of the fact that it was one that would factor. Specifically, I could factor it using the shortcut. Either the shortcut or the greatest common factor. Beautiful. Love both of those. They're easy enough to do. With that 3 in front of this, am I going to be able to do the shortcut? At least not without factoring it out, but is a 3 going to come nicely out of all of the things? No, which means it doesn't sound nice to factor. Could I maybe do AC method? Maybe, but if I can avoid it, I avoid it. It also means, since this 3 is not going to come nicely off of everything, completing the square is not going to be the nice thing to do. Can I solve by square roots? No, because I have a regular x. Can't do square roots, don't want to factor, at least don't want to try, maybe it can. Don't want to do completing the square, what's the other option? The formula. In order to do the quadratic formula, what must be first true about the equation? Standard form equal to 0. Okay, so I add 2. Doesn't combine with any of those. So 3x squared minus 3x plus 2 equals 0. Get it equal to 0, then identify A, B, and C. What's A? 3, the number in front of x squared. What's B?
3.
No. Negative 3. Be careful of that. What's C? 2. Once I've identified A, B, and C, what do I do with it? Plug it into the ugliness. It's ugly, but it's easy to work with. The quadratic formula says negative B, in this case negative 3, plus or minus the square root of B squared If you do not put that -3 in parentheses before you square it, it will not work. -4 times 3 times 2 all over 2 times 3. I simplify what I can. Remember, simplify this. -3 is just +3. 2 times 3 is 6. When I'm simplifying the rest of it, do I put the square root in the calculator or do I not? Do not. Leave the square root symbol here. Put the stuff inside into your calculator. There's a negative inside of my square root telling me what is true. It's an imaginary answer. Wait a second. What did I say earlier about imaginaries with systems? You're not going to get them. Wow! If this was just a straight quadratic equation, you would end up dealing with that I times the square root of 15 all over 6. And the square root of 15 wouldn't simplify, which means that would be my final answer. But systems of equations should not have imaginary solutions. Therefore, my answer is no real solution. If you say no solution, it's technically wrong. There is an imaginary solution. Just lives completely in the complex plane, in the imaginary numbers plane. I got one final example. Solving a system of equations. Solving a non-linear system of equations. What do I need to do first? Get y alone on one of the equations. Done. Next thing. Plug it in. Substitute. This y is alone. I'm going to replace it right here. When I substitute it in, I should put it in parentheses. Are the parentheses doing anything on this one? No. When they're both y alone, the parentheses are not going to do anything. Is that the only case where the parentheses are not going to do anything? No. But it is the one that is always not going to do anything. If y is 100% alone on both equations, you just set them both equal. First thing I notice is I have some like terms. Always get your like terms together first. I could subtract the 4, I could subtract the 8. It doesn't matter. I might have to move them to the other side, but sure, let's subtract 4. In any form of factoring, any form of factoring. Let me try this again. In any form of solving, this is a terrible setup. You never want x's on the opposite sides of the equal sign. So I want to get them together. Do you want to move the x squared or the negative 4x? I would move the x squared because it's negative. Do I want my x squareds to be negative if they don't have to be? No. Is it the end of the world if they are? No. But if I'm manipulating the equation anyway, I might as well make it positive. 0 equals, don't forget standard form, x squared minus 4x plus 4. Is this a setup that would be good to at least try factoring on? Yeah, there's a 1 in front of x squared. It would be good to at least try. Is this a form that would be okay to try completing the square on? Yeah, because there's a 1 in front of the x squared and this is even. So completing the square wouldn't be bad here. Is this a good one to solve by square roots? No, you cannot solve by square roots because of the regular x. Can I solve any equation by quadratic formula? Yeah, as long as it's in standard form equal to 0, you can always use quadratic formula. I'm going to try factoring first. Factoring is the easiest when the leading coefficient is 1. How do I factor again? Find two numbers that multiply to... That's if I'm doing the full AC method. I'm doing shortcut. So it just has to multiply to C, but add to B. Two things that multiply to 4 and add to negative 4. Negative 2, negative 2. Wait a second. They're the same number. We've seen that before, right? X does not equal negative 2. 0 equals x minus 2, or more commonly we write it as x minus 2 squared. Hey, this one was set up for completing the square. We literally just completed the square. Now, we wouldn't finish completing the square. That's the harder method to do on this one. Because I can continue to solve by factoring because it's equal to 0. What's the only way I square something and it gets 0? What do you have to square to get 0? 0, which means this x minus 2 is equal to 0. X equals 2. I still solved by factoring. Could I solve by square roots? Yes. Square root to both sides. X minus 2 equals positive and negative 0, which is just 0, and x is 2. Could I have split it right here? Yes. I still would have gotten x equals 2 and x equals 2. Do I need x equals 2 twice? No. Am I done with this problem? No. It's a system. How do I finish it? Plug it back in. First equation, second equation. In this case, the second one would be easier. It's linear. So, y equals negative 4 times 2 plus 8. Zero. If when you're factoring, it factors to something like this, generally speaking, that number should be 0. There's my solution, my singular solution. How are we feeling about systems that are nonlinear? Probably depends on how you're feeling about solving quadratics. To be honest, they come in hand in hand. Okay, your assignment's a book assignment, page 132. Question numbers 1 through 4, skip up to 13, and then 16 through 20.